So, my friend Manic decided to retexture a Vulpur avatar for me. The cool thing is, this thing has audio link on it. Basically, in certain VR chat worlds, you can have stuff that's glowing and reacts to the music being played. Me being a physicist, I had the bright idea of having all the glowy parts be a bunch of physics equations. Manic was kind enough to add them as part of the avatar. And here is the result. Yup. I am indeed a nerd. There are 21 equations that's on this avatar right now, and they cover basically all the physics that I know. First ones that you see are these two, which are part of Maxwell's equations. This is Gauss's law for magnetic fields, which basically says that no magnetic monopoles exist, while this is Gauss's law for the electric field, which basically says that electric fields are generated by charged particles. Of course, the other two Maxwell equations are behind my ears. This is Faraday's law, basically saying that a changing magnetic field causes an electric field. And this is Ampere's law, where it basically says a magnetic field is caused by an electric current. And you have Maxwell's correction term added in. Going down the list, you have the Navier-Stokes equations on my arms. On this arm, you have mass conservation for a fluid and momentum conservation for a fluid. And on this arm, this whole big thing is energy conservation for a fluid. On my chest, we have the equations for particles that are moving relativistically fast. This is the Klein-Gordon equation and the Dirac equation. The Klein-Gordon equation describes quantum mechanical particles that have spin 0, and the Dirac equation describes particles with spin 1/2. And below that, we have the Schrodinger's equation, which describes quantum mechanical particles, except we're now talking about slow-moving particles that are not relativistic. Though speaking about relativity, this is actually the full version of E equals mc squared in 4-vector notation. It's worth noting that energy has only one component, while momentum has 3 components for 3 spatial components. And this term here is invariant to whatever reference frame you're using. It doesn't change. That's rest mass and the speed of light. On the other side of my butt, we have Einstein's field equation for general relativity. This equation just tells us that gravity is really just curvature of spacetime caused by mass. Now you're probably wondering, where is Newton's second law in all this? It's a pretty famous equation, right? Well, I decided to use equations that are a little bit more general for classical mechanics. On my thighs, we have the definition of a Lagrangian and the definition of a Hamiltonian, and of course the 2 motion equations you get using the Hamiltonian formalism. And on my back, we have the Euler-Lagrange equation, which uses the Lagrangian formulation to get motion equations. Funny enough, the Lagrangian is actually a little bit more general and doesn't strictly apply to classical mechanics. For example, this big thing that's on my back here is the action for quantum electrodynamics. Basically, it describes quantum particles that are moving relativistically fast using the electromagnetic force. Yeah, it's a big one, right? Forgive me, I decided to not have the action for quantum chromodynamics on my body. I think that one would have been a little bit too much, just a little bit. And lastly, we have the definition of entropy on my tail, as well as the distribution function for fermions, and the distribution function for bosons. And that's pretty much it. Those are all the equations that are on my body right now. And you'll probably see me wear this avatar when I'm dancing at the clubs in VR. Anyway, y'all, thank you so much for watching, and I'll see you in the next video. By the way, I think it's really funny to have Einstein's field equation on my butt, because my ass has mass and mass creates gravity.